Julie has 2 5-cents and 3 10-cents coin in her pocket. She takes out 2 coins at random, one after the other without replacement. Copy and complete the tree diagram below to show the possible outcomes. And so here we have this tree diagram, and our goal is to complete it in order to show the possible outcomes. Now, it's important to note that she takes one after the other without replacement. So when she takes out one, she doesn't replace it back. And so what does she have in her pocket? Well, it says that she has 2 5-cents and 3 10-cent coins. So so what is the probability of her getting a 5-cent, right? The first time. So remember, she takes 2 coins out, one after the other. So the first time, what is the probability of her getting a 5-cent? Well, there are 1, 2, 3, 4, 5 coins altogether. So 5 will be as the denominator. And there are only 2 5-cents. And so that means that the probability of her getting a 5-cent would be 2 over 5. And so that makes sense. It's 2 over 5. Now we need to figure out what's the probability of her getting a 10-cent, right? The first time around, what's the probability of her getting a 10-cent? Well, we know that there are 5 options, 5 total options, all right? And so it'll be, the denominator would have to be 5 because there are five total options, okay? But there are only 3 10-cents. There's 1, 2, 3. So that's why the probability of her getting a 10-cent is going to be 3 over 5 because there are 3 10-cents and there are 5 possible coins to choose from. And so for this one, it's 2 over 5, and for this one, it's 3 over 5. Now, let's move on. So after she already chose 1 5-cent, what is the probability that she will choose another 5-cent? Okay. Now, it's important to understand how we're going to get our answer. Remember, when she choose 1 5-cent, that 5-cent is no longer there, right? She does not replace it, right? So because she takes it one after the other without replacement. And so when she's about to take this next 5-cent, right? How many coins does she have to choose from? Well, she only have four coins to choose from because it's going to be 1, 2, 3, 4, right? She cannot choose this particular one because it's not there, right? She doesn't replace it back. Now, how many 5-cents are there? Well, there's only 1 5-cent. There's only 1 5-cent because the other 5-cents was taken. So the probability that she chooses a 5-cent after she already chose a 5-cent before is going to be 1 over 4. Okay, now let's move on to the next one, right? So here we know that that she chose 5-cents, right? What's the probability of her after she chose this 5-cents? What's the probability of her choosing a 10-cent, right? Now remember, she already chose a 5-cents. So what is the total amount of coins that are left? Well, it's only 4 because she already chose 5-cents. So it's only 1, 2, 3, 4. What's the probability of her selecting a 10-cents after she already selected a 5-cent on the first try? Well, the probability of her selecting a 10-cent is going to be 3 over 4 because there are 3 10-cents, all right? There are 3 10-cents and there are 4 coins altogether, all right? There are 4 coins left. And so that's how we get 1 over 4 and 3 over 4 here. Now, okay, let's move on to this particular one. So let me erase our link. So what is this one saying? This one is saying that she already selected a 10-cents. Okay, so she already selected a 10-cents. So what is the probability of her selecting a 5-cents after on the first try, she already selected a 10-cents. And so since she already selected a 10-cents, that means that we have to remove this 10-cents because the 10-cents already selected. And so since she already selected a 10-cents, they want us to figure out what is the probability of her selecting a 5-cents on the second try. Now, how many coins does she have to choose from? Well, she have 1, 2, 3, 4 coins to choose from, right? 4 coins in total that are left. But how many But how many 5 cents are left, right? How many 5 cents are there? Well, there are 2 5 cents, right? 2 5 cents are there. And so it's going to be 2 over 4. So the probability of her selecting a 5 cents on the second try after she selected a 10 cents on the first try is 2 over 4. Now let's move on to this one. Now this one is asking us, what is the probability of her selecting a 10 cents on the second try after she selected a 10 cents on the first try? Now, since she selected a 10 cents on the first try and she does not replace it back, that means that this 10 cents is no longer there. And so what that means is that the total amount of coins that she have to choose from, the total amount of coins that are left is going to be 4. 1, 2, 3, 4, not 5. It's 4 because we removed one. And that one that we removed was a 10 cents. Now, how many 10 cents coins are left? Well, there are 2 10 cents coins, so it's going to be 1, 2. So that's why we have 2 over 4, because there are 2 10 cents coins and there are 4 total coins to choose from. And so this is the completed tree diagram. Now we're going to use this tree diagram, right? Now we're going to use this tree diagram in order to help us to answer the rest of these questions. And it says, use your tree diagram to calculate the probability that she takes out 2 coins of the same kind. 2 coins of the same kind. And so what that means is that let's figure out the probability of her getting 2 5 cents coins, right? Back to back. All right. So 5 cents coin and then 5 cents coin. Well, the probability of her getting a 5 cents on the first try is 2 over 5. And the probability of her getting a 5 cents on the second try after she got a 5 cents on the first try is going to be 1 over 4. So you're going to say 2 over 5 multiplied by 1 over 4. That's the probability of getting a 5 cents and then a 5 cents again. Okay, so we have to multiply these two. That is one way that she can get 2 coins that are of the same kind, if both of them are 5 cents. Now, she could get 2 coins of the same kind in another way, right? If both of them are 10 cents. So she can get she could get a 10 cents on the first try, and the probability of that is 3 over 5. And then she can get a 10 cents on the second try, and the probability of that is 2 over 4 if we know that she got a 10 cents on the first try. And so 3 over 5, that's the probability of her getting a 10 cents the first time, and then 2 over 4 is the probability of her getting a 10 cents again, provided that she got a 10 cents on the first try. And so we have 3 over 4 multiplied by 2 over 4. I'm sorry, so we have 3 over 5 multiplied by 2 over 4. And so this right here is the probability of her getting a 10 cents twice, on the first try and then on the second try. And this is the probability of her getting a 5 cents twice, 2 over 5 on the first try, and 1 over 4 for the second try. And so we multiply and then we add. So this is both 5 cents, this is both 10 cents. So when we multiply 2 times 1, we multiply 2 times 1, we get 2, and 5 times 4 is 20. For this one, we say 3 times 2, and 3 times 2 is 6. And then we have 5 times 4, which is 20. And so we add, we say 2 plus 6 is 8, and we keep the denominator the same, which is 20. And so what we do here is we divide, so we say 8 divided by 20, and 8 divided by 20 is 0.4. And so the probability that she takes out 2 coins of the same kind is 0.4. Next, we want to figure out, it says use your tree diagram to calculate the probability that she is left with 25 cents in her pocket. Okay, so the probability that she's left with 25 cents in her pocket. Okay, so let's look at what she have here, right? So let's put out the options that she have. So how many 5 cents that she have? She have 2 5 cents, okay? And now how many 10 cents does she have? She have 3 10 cents, right? So we have 10 cents, right? And we have 10 cents, and then we have 10 cents. Okay, so they're saying calculate the probability that she's left with 25 cents in her pocket. Now there are 2 ways for her to be left with 25 cents in her pocket. The first way is that she can take 5 cents, right? So if she take 5 cents, right, first, and then she take 10 cents second, that means that she would take out 15 cents altogether, and she would be left with 2 10 cents and 1 5 cents, which means that she would be left with 25 cents. Again, there's one way to do this. We can take 5 cents first on the first try, and then you can take 10 cents on the second try, and then what would that leave you? That would leave you with 3 coins, 10 cents, 10 cents, and a 5 cents, and that would leave you with 25 cents. So that's one way to do it, right? She could take a 5 cents and then a 10 cents. Another way to do it, she could take a 10 cents first, right? So let me erase this. Another way to do it is that she can take a 10 cents first. So she can take a 10 cents first, and then she could take a 5 cents, all right? And so if she take a 10 cents first, and then a 5 cents, she'll still be left with 2 10 cents and 1 5 cents. So she'll still be left with 25 cents. And so there are 2 ways to do it. So we're gonna do the 2 ways and then add them. So it's a probability that she gets a 5 cents first on the first try. That's going to be 2 over 5. What's the probability that if she gets a 5 cents on the first try, that she gets a 10 cents on the second try? Well, that's going to be 3 over 4. So we have 2 over 5 multiplied by 3 over 4. And that's what we have. The probability of a 5 cents, then a 10 cents. Or means multiply, or means add, okay? She can take a 10 cents first, and the probability of her getting a 10 cents first would be 3 over 5. That's what we have. And then she could take a 5 cents next. And the probability of her taking a 5 cents after she already took a 10 cents would be 2 over 4. And so we have to compute. So we have 2 times 3, which is 6. And we have 5 times 4, which is 20. And we have 3 times 2, which is 6. And we have 5 times 4, which is 20. And so it's going to be 6 over 20 plus 6 over 20. And that's going to be 12 over 20. And then when we divide, we get 0.6. And so the probability that she's left with 25 cents in her pocket is 0.6. And that's the answer to this particular question.